All right, let's talk about the AWS Transit Gateway. Now, I know a lot of us use it, but mostly as just a simple cloud router, right? But its real power, the stuff that solves the really tough networking problems, is hidden in its advanced features. And today, we're going to show you how to master them.
So what's the real difference? I mean, a good network, yeah, it moves packets from A to B. But a great network? It moves them securely, super efficiently, and at a massive scale, even when things get crazy. It's about anticipating problems before they even happen.
And that's exactly what this is all about. We're going way beyond the basics to unlock the tools that define an expert-level cloud network. It's time to seriously level up your TGW game.
Okay, first up, we're tackling a problem that is an absolute silent killer for security folks: asymmetric routing. This is one of those things where your super expensive, state-of-the-art firewalls can become completely blind to threats. It's a real black hole for security.
So, picture this. You've set up this beautiful, centralized firewall in its own dedicated VPC. Everything looks perfect. Traffic goes out from your app through the firewall, gets inspected, no problem. But then, the return traffic takes a different, shorter path back and completely bypasses the firewall. Your firewall, which is a stateful device, it only sees one side of the conversation. It gets this return packet, has no record of the session, and just drops it. Your connection fails, and you're left just scratching your head wondering what went wrong.
And this, right here, is the textbook definition. Traffic goes out one way, comes back another. Why? Well, because AWS routing is always going to prefer the shortest, most efficient path. So that return traffic from VPC B sees the direct shot back to VPC A through the transit gateway as the best route. It totally skips the firewall VPC it came from. And this creates that one-way traffic that stateful devices just can't handle.
So the big question is, how do we fix it? Well, AWS gave us a purpose-built solution, and it's called Appliance mode. When you flip this switch on the VPC attachment where your firewall lives, you're basically telling the transit gateway, hey, listen up. For any traffic that comes through this attachment, I need you to make absolutely sure the return traffic goes back out the exact same way. It just locks the path in place. But, and this is a huge but, you have to enable this when you create the attachment. You cannot go back and change it later.
Now this slide is your practical cheat sheet. You absolutely want to enable appliance mode for any VPC that's hosting a stateful inspection device. We're talking your Palo Altos, your FortiGates, an IDS system, or even an SD-WAN hub. But you want to avoid it for your normal application VPCs. Turning it on where it's not needed just adds unnecessary complexity and can constrain your routing.
All right, so we've secured our traffic flow. That's awesome. But what about scaling it? Let's talk about the next big challenge. How do we deal with growing bandwidth demands and, just as importantly, make sure our on-prem connections are actually resilient?
You know, this is such a classic scaling problem. A single VPN connection has a hard cap on bandwidth, but way more importantly, it's a single point of failure. If that one connection drops, your entire link between your data center and the cloud is just gone. And that's not a risk most businesses are willing to take.
The answer is something called Equal Cost Multipath, or ECMP. And this slide shows you exactly how it works. You just set up multiple connections, say a few VPNs, and then, using the BGP routing protocol, you advertise the exact same network routes over all of them. The transit gateway sees these identical paths and thinks, hey, I've got multiple ways to get there. And then it just automatically starts spraying the traffic across all the available connections. You get more bandwidth and instant failover if one of them goes down. It's beautiful.
Okay, now listen up, because this is a massively important detail that trips up so many people. ECMP works like a charm for your external connections, your VPNs, your direct connects, but it does not apply to the attachments between the transit gateway and your VPCs. And you might be asking, why not? Well, it's because a VPC attachment is pinned to a single elastic network interface in each availability zone. You just can't load balance traffic across multiple attachments into the same VPC.
Okay, let's shift gears a bit and talk about a more specialized but incredibly powerful feature: Multicast. You know, for the longest time, this was a huge gap in cloud networking. People had to build these really complex workarounds. But now, Transit Gateway can handle it natively.
So, who actually uses this stuff? Well, think about any time one source needs to send the exact same packet of data to a whole bunch of receivers at the same time. It is huge in finance for blasting real-time market data to thousands of trading servers. Media companies use it for live video streams, and IoT platforms use it to push updates to countless devices all at once. It's all about that one-to-many efficiency.
Now, the setup might sound a little intimidating, but it really just breaks down into these 4 logical steps. First, you create what's called a multicast domain. Think of it like a container for your multicast traffic. Then, you just add your VPCs to it. And here's the key part. Unlike on-prem networks, you have to explicitly tell the transit gateway who's who. You have to say, hey, this EC2 instance right here is my source, and these other instances over there are my receivers.
But before you rush off to redesign your whole network, you have to know the boundaries here. TGW Multicast is a cloud-native solution. That means it doesn't work across different AWS regions, it doesn't work over TGW peering, and, critically, you cannot send multicast traffic back to your on-prem data center over a VPN or Direct Connect. It's really designed for communication within your AWS environment.
So, we've covered Symmetry for security, scaling with ECMP, and the specialized case of multicast. Now, let's see how all these advanced features come together in one of the most common enterprise architectures we see today.
Honestly, this is the gold standard for modern hybrid networks. Companies use SD-WAN solutions, like a Cisco Viptela or a Fortinet, to manage all their branch offices. They then build an SD-WAN hub inside AWS, which connects directly to the transit gateway. And just like that, the TGW becomes the central nervous system for the entire organization, seamlessly connecting every single branch office to every single VPC, all while using features like Appliance mode for security and ECMP for that critical connectivity and redundancy.
Whew! Okay, we have covered a lot of ground. We've looked at the problems, we've looked at the advanced solutions. Now it's time to put that new knowledge to the test. I'm going to flash 3 questions on the screen. These are the kinds of questions that separate the pros from the novices in a high-level cloud networking interview. So let's see how you do. All right, first up, the security question. Why do we absolutely need appliance mode when we're inspecting traffic? The big reason? It's to solve asymmetric routing. You gotta force that return traffic back through the firewall to maintain state so your sessions don't get dropped.
Question number 2, the scaling and redundancy test. What are the specific ingredients needed for TGW to turn on ECMP? You need multiple VPN or Direct Connect attachments, and they all have to be advertising the exact same prefixes using BGP. That's what creates those multiple equal cost paths in the route table.
And finally, our third challenge, knowing the boundaries. What are those big gotchas with TGW Multicast? Remember, it's cloud only. That means no cross-region, no peering, and absolutely no connectivity back to your on-premises network. Hey, if you nailed those 3 questions, congratulations. You're really thinking like a TGW expert. Mastering these tools isn't just about solving the problems you have today. It's about building a network that is secure, scalable, and truly ready for whatever comes next. Thanks for joining us.